I mean, this is the central question. So Stephen's initial calculation, 1974, was that this radiation, the Hawking radiation, is information-less. It's information-free. So it's not gone away. It's not disappeared, the black hole. It's turned into the radiation, right? But his calculation said there's no information in that. It's what's called thermal, purely thermal. Not surprising if you think about it, because it's been kind of shaken out of the vacuum of space. So it's certainly, you would think, got nothing to do with the stuff that falls in. This is something to do with the horizon. It's not anything to do with the singularity, this stuff. So out it comes, and the calculation is very clear. So that would suggest, as you said, that the information, any record of anything that fell in, will have been erased. Mm-hmm. The energy will be the same, right? The energy is conserved. The black hole hasn't vanished. It's turned into radiation, but the radiation contains no trace of anything that fell in. That is weird, as you said, because if you think, let's imagine, you might say, well, what's the difference? What if I get this piece of paper and set fire to it? It goes, and there's just stuff, ashes and radiation. Yes, but in principle, then if you could just measure everything, mm-hmm. which you can't, but if you could, then you could reconstruct the information on the page. Right. And you can see why, because it's got something. What's happening when you burn it is chemical reactions and there's oxidation, whatever it is, but you can trace everything back. So you can say all the atoms and things are still around, and there it is. In a black hole, you can't. So it wasn't surprising. What was surprising is that it appears there is a calculation that tells you that black holes erase everything. And as you said, the laws of nature are quite clear on this. Information does not get destroyed in the universe. It gets scrambled so you can never reconstruct it, but it doesn't get destroyed. So that's what bothered everybody for a very long time.